Today we are going to prove that this limit is equal to 1. And when we look at this expression sine theta over theta, we think of sandwich theorem. And why is that? Because this is an expression involving a polynomial expression 1 over theta and a trigonometric expression sine theta. So whenever we have a product of a polynomial expression and a trigonometric expression, normally we find the limits of those expressions using sandwich theorem. So what is sandwich theorem? Sandwich theorem is basically, this is a basic diagram for sandwich theorem, and the sandwich theorem states that whenever a function is sandwiched between two functions, like f of x here is sandwiched between these two functions g of x and h of x, meaning that f of x is greater than h of x and g of x is greater than f of x. So whenever this is the case and we want to find a limit when x approaches c, so this is x-axis and we are approaching c. So whenever we approach c, we can see that h of x and g of x, they both approach L. Because f of x is sandwiched between those two functions g of x and h of x, it will also approach L. So this is basically sandwich theorem. So we need three functions, g of x, f of x and h of x, and we need a function to be in between two functions. And if we look at the statement for the sandwich theorem, it uses this equal sign as well, that h of x is less than or equal to f of x and less than or equal to g of x. This equal to sign, basically it helps us because when we use sandwich theorem, we are generally dealing with a trigonometric function, and trigonometric functions have values ranging from -1 to 1. I'm talking about cos theta and sine theta here. So they have values from -1 to 1, and they can have values of -1 and 1. So we have to include those values. So that's why we use this equal to sign. So what we are interested in sine theta over theta, because we are finding the limit for that particular function, and we need three functions and we need inequalities. So this can be our starting argument, the range of sine theta, because our function involves sine theta. So we know that sine theta has values from -1 till 1. So this helps us in getting the inequalities which we need to apply sandwich theorem, and also we have three things now. But we don't need sine theta, we need sine theta over theta. So we divide sine theta by theta, and we divide all the sides basically by theta. And we are considering theta to be greater than 0 here, meaning that we are approaching theta is equal to 0 from the right hand side. So for a limit to exist, a left hand and right hand limits both must exist. We must have the function approaching same value from the left and from the right hand side for a limit to exist. So firstly, we are considering the right handed limit. So we have -1 over theta at one side, and we have 1 over theta on the right hand on the other side, and sine theta over theta is sandwiched between those two things. So for us to use sandwich theorem, these extreme functions, they must approach to same value, so that this we can say that according to sandwich theorem, this middle value which is stuck in between those two things have the same limit as well. So we are taking theta to be a very small positive number, because we are approaching from the right hand side, and from the on the right hand side we have positive numbers. Theta is just like x. Normally we use x when we talk about functions, and x is our independent variable. Here I have considered independent variable to be theta. Doesn't matter, whatever the independent variable. So we are interested in finding the limit of these extreme functions. And what is limit? The limit is basically the value which a function approaches when the independent variable approaches a certain value. So the independent variable is approaching, or theta is approaching, the value of 0 from the right hand side. So minus 1 over theta will approach negative infinity, because when we divide 1 by a very small positive number, the overall number gets huge. So it will be minus a very large number, which is actually a small number, very small number. And when we divide 1 by that same number, we approach positive infinity. We approach a very large positive number. So these two things aren't approaching the same number, so we can't use sandwich theorem here. We have run into a problem. So what should we do? How can we solve this problem? So what we do is that we use graphical approach to think about this, the limit of this function. And I have drawn a figure for y is equal to theta and y is equal to sine theta. So sine theta is this curvy thing, and y is equal to theta is a straight line, or is a line. Well, this exactly doesn't look exactly like y is equal to theta, because y is equal to theta bisects the first and third quadrant. So but it's a rough diagram. So this is a straight line, y is equal to theta, and this is y is equal to sine theta, and theta is this independent variable, and it is along this axis, and it has values in terms of pi. Theta is in radians here. So because we know that theta is an angle, we are taking sine of that angle. So this is an angle, and angle can be in two forms. Generally, which the forms which are used are degrees and radians. So here we can see that along the this horizontal axis we have the values in terms of pi. So this is not in terms of degrees. We have angles in terms of radians, and we have this straight line y is equal to theta. So we can see from this figure that we are approaching theta here. Theta is equal to 0, and we are approaching it from the right hand side, and the theta gets smaller and smaller, but is not equal to 0. It will approach 0. It will be a very small positive number. So from this diagram it's not as clear, but if you draw this diagram in Desmos, a software, a graphical software, so you can see that you have to zoom in. But if you zoom in Desmos, you will see that for positive values, for theta greater than 0, this line will always be greater than this curve, this sine theta curve. Not as apparent from this figure, but if you draw a graph in Desmos, you will be able to see this. So I've written that as apparent from figure 1, theta is greater than 0. For theta is greater than 0 because we are considering right hand limit. Sine theta is less than theta. And I will prove this through another diagram, that sine theta is less than theta, if it's not clear through this diagram. But we are saying that sine theta is less than theta for theta greater than 0. That means that sine theta over theta is less than 1. Sine theta is smaller than theta. So when we take the ratio, numerator will always be the smaller than the denominator. So the overall ratio will always be less than 1. So we're talking about sine theta over theta because this was our function. We have to find the limit of this function when theta is approaching 0. And right now we are approaching theta is equal to 0 from the right hand side. So the first thing which we saw was that sine theta is less than theta for theta is greater than 0. And we will use that thing in a few moments. The second thing which I want to talk about is that if you look at this diagram, y is equal to theta, this basically, what does it tell us? That y is equal to theta. Whenever you take slope of this line, it will be 1 because the change in theta will be equal to the change in y. So the slope of this line is 1, and the slope of sine theta over theta, this is less than 1. It will never be equal to 1. Even if we put 0 over 0 or if we put theta is equal to 0 in this expression, we get sine 0 over 0, which is 0 over 0, which is the problem basically. That's why we can't directly find the limit of this thing, because when we put theta is equal to 0, we get 0 over 0. And sine theta over theta will always be less than 1. So this fact that sine theta over theta will always be less than 1 can be useful. We have two things now which we can use. That firstly, y is equal to 1 is a horizontal line, and secondly, that sine theta over theta for theta greater than 0, we are talking about positive x-axis here, or positive theta axis here I should say, that sine theta over theta, this will always be less than 1. So we have two things, but in sandwich theorem we need three things. So we must think of the third thing, which is further less than sine theta over theta. And cos theta happens to be that function which is less than sine theta over theta for theta is greater than 0. So we will use this cos theta by saying that tan theta is greater than theta, and if you draw the diagram for this tan theta, for tan theta and theta, y is equal to theta and y is equal to tan theta, for and if you look at the diagram, you will see that tan theta will be greater than theta for theta for positive theta, basically I'm talking about positive theta, because we are finding the right hand limit. So because tan gets undefined at, or goes to positive infinity for pi over 2, so I'm not taking pi over 2 here, and I'm not taking 0 either, because we are not interested in what happens at 0. We are interested in what happens when we move closer and closer to 0. So I am saying that tan theta is greater than theta for this range of theta, and tan theta is basically sine theta over cos theta. And you will understand that, or you will get that why I'm talking about tan theta here, because clearly a few moments ago I was talking about cos theta and making use of cos theta for sandwich theorem. So tan theta is sine theta over cos theta. It will be greater than theta, and we are interested in basically sine theta over theta, so we don't need here, we don't need cos theta in the denominator, so we multiply by cos theta on both sides. What we get is sine theta is greater than theta into cos theta, and so we have sine theta now. We are interested in sine theta over theta, so I'm dividing both sides by theta. We get sine theta over theta, which is greater than theta into cos theta over theta. Theta and theta cancel out. We are left with sine theta over theta, which is greater than cos theta. So this is basically what we saw in the diagram, that sine theta over theta is always greater than cos theta for theta greater than 0. And so we have now our two inequalities which we need in order to use sandwich theorem. One inequality is this, that sine theta over theta is greater than cos theta, and the second inequality is that for theta greater than 0, sine theta is less than theta. So the combined inequality becomes sine theta over theta is less than is greater than cos theta and is less than 1. And this 1 basically I talked about this, that sine theta over theta will always be less than 1 for theta is greater than 0. So this is the combined inequality, and we have our desired expression in the middle, and we have our extreme functions on the we have cos theta and 1, and sine theta over theta is sandwiched between these two functions. So what are we interested in? We are interested in finding the limits of the extremes and see whether they approach the same value, so that our middle function approaches the same value. So and approaching theta is equal to 0 from the right hand side, so theta approaches 0 plus. This means that theta is approaching 0 from the right hand side, and same with this one, and same with this sine theta over theta. So cos theta is basically a continuous function. It doesn't break at any point, or it is not undefined at any point, I should say. So that means that the value of cos theta at any theta is equal to the limit for that value. So if theta is approaching 0, we can easily find this limit by putting 0 in this function. So this limit will be equal to cos of 0, and cos of 0 is 1, and this even doesn't even involve theta, so this is 1, so it will remain 1. So cos 0 is 1. This we have 1 on the other side, so that means that what we were looking for, our desired limit, is sandwiched between these two things, and both of those things are 1. They are approaching the same value. So they are approaching the same value. The sine theta over theta will also be approaching the same value because it is sandwiched between those two things. And we didn't use equal sign here because when we looked at our figures, it was clear from the figures that we we got only less than or greater than. Sine theta was less than theta for positive values of theta, and cos theta was less than sine theta over theta. So this limit is 1. I am saying that this limit is equal to 1 because when we approach 0 from the right hand side. But we know that for a limit to exist, it must have the same left hand limit and the right hand limit. And also we saw that two things from the figures, that firstly cos theta is less than we saw that sine theta is less than theta for positive values of theta, and I said that I would prove it through another figure, and now we will prove that sine theta is less than theta for positive values of theta. And secondly, I said that tan theta is greater than theta when you look at its graph. So I'll prove these two things because these are the two things which we use to find this limit, and these things must be true for this limit to be equal to 1, because this gets us to the fact that cos theta or sine theta over theta is greater than cos theta, and this thing is basically sine theta is less than theta. So we need these two things to be true. So firstly, I'm going to prove that sine theta is less than theta. For that, I have drawn this unit circle, and we have taken a point at this unit circle, and I've drawn a right angle triangle using this point. I have drawn a perpendicular from this point to the theta axis, and obviously the distance from this point to the origin is 1 because this is a unit circle and radius is equal to 1. And this angle, I am taking this angle in radians, theta is in radians. So we need to, because we are interested in finding proving that sine theta is less than theta, so we must have sine theta. So firstly, this arc length is equal to theta. And why is that? Because when we use the formula S is equal to r theta, this is a formula. S is basically the arc length, and this length from this point till the axis, and r is the radius of the circle, which is 1 in this case because it's a unit circle, and theta is basically our angle in radians. So when we put r is equal to 1, we get S is equal to theta. What does this mean? This means that this arc length, this curved thing, it has length is equal to theta, and theta is the angle, and it's a real number. Theta is in radians. So it only makes sense that this arc length is equal to theta because it's a length, and length must be a real number. So if we took theta to be in degrees, this will be in a length, and it won't make sense that this is in degrees. So this is a length and it must be a real number, and it only happens when we take theta is in radians, and here this arc length is equal to theta because it's a unit circle. So we are interested in sine theta, and sine theta is equal to perpendicular over hypotenuse. So we don't know what the perpendicular is here in this triangle, so perpendicular will remain as it is, and hypotenuse is this distance from origin to this point the point which we have taken on the unit circle. So uh, it is 1. So hypotenuse is 1, sine theta is equal to perpendicular of 1. So this means that perpendicular is equal to sine theta, that this length, this perpendicular of the right angle triangle, is basically our sine theta. So this curved length is, or this arc length is theta, and this straight line is sine theta. And you know, we can easily see that this straight line is smaller than this curved line. There's a theorem as well that the shortest distance from a point to a line is the perpendicular. No matter what other path you take, that will always be longer than this perpendicular. So this curve or this arc length or this theta is basically greater than this perpendicular. So theta is greater than sine theta. So this is what we needed to prove for using our sandwich theorem, or for our limit to be true. So clearly sine theta is less than theta from the figure. So it has been proved. And the second thing which we needed to prove was that tan theta is greater than theta. Now I'm taking the unit circle again, and now I'm considering a point outside this unit circle, and I have drawn a perpendicular from that point to the horizontal axis, and we are interested in proving an inequality which involves tan theta. So we are interested in tan theta, so we will use the formula for tan theta, and tan theta is equal to perpendicular over base. In this case, the perpendicular is we don't know what perpendicular is. In this case, so here our base is 1. We have constructed the triangle in that way that our base is exactly this radius, and radius is 1. So perpendicular over base becomes perpendicular over 1, and from here perpendicular is equal to tan theta. So this perpendicular is tan theta, and this curved or this arc length is theta, as in the previous case, because theta is in radians. So we will talk, or we will consider area this time around. I'm going to find the area for this curved portion and for this triangle. So firstly, considering the area for triangle, so this is a right angle triangle, and area of this right angle triangle will be half into base into height, and base is 1, base of this triangle is 1, and height is tan theta. So half into 1 into tan theta becomes half tan theta. We have found the area for this triangle. Now considering the area of sector, or so the area of sector is basically half r square theta. And where did this formula come from? I'll be going to explain this next. So we are interested in finding the formula for area of sector, and firstly for that we need to find the area of, or we must know the area of whole circle. So area of whole circle is equal to pi r square, and we are interested in area of sector. So that will be the angle divided by the total angle of the circle into the area of the circle. So the piece or the sector in which we are interested has the area theta, and the total area or the total central angle of the circle is 2 pi, and the angle of, or the area of the circle is pi r square. So in this way, pi and pi gets both of these pi's get cancel out, and we are left with half r square theta. So here is our formula, half r square theta, and we have a unit circle, so r is equal to 1, so we will have the area of sector equal to half into 1 squared into theta, which is half theta. And when we compare the areas of that triangle and the area of the sector, we get the inequality. Area of the sector from the figure, we can clearly see that it is less than the area of triangle. The area of sector is half theta and the area of triangle is half tan theta. So half and half cancel out. We are left with theta is less than tan theta, and this was our goal. We wanted to prove that tan theta is greater than theta. So both of those inequalities needed to be proved in order for us to say that the right-handed limit was equal to 1, and we have proved those inequalities. So what remains is that the left-handed limit must also be equal to 1 for this limit to be equal to 1. And if we see, this is sine theta over theta, and this is y is equal to 1, and this is cos theta. Even when theta is less than 0, a negative number, still sine theta over theta approaches, it is sandwiched between y is equal to 1 and y is equal to cos theta, and it approaches 1. Why is that the case? Because we have theta as we have a negative value for theta, and sine theta is an odd function. So when we take sine of a negative value, it becomes negative times sine of that value, and there is a negative sign which comes with sine theta in the numerator. So sine theta becomes negative times sine theta for negative theta, and we are interested in sine theta over theta. So in the denominator, we also must divide by the value of theta, which is negative. So the negative and negative cancel out in numerator and denominator, and we end up with the same sine theta over theta. So that also approaches 1. So I'm going to prove that also. So now I'm considering theta to be less than 0. We are finding the left-handed limit. So everything will be reversed. For theta less than 0, sine theta will not be less than theta, it will be greater than theta. But both of those values will be negative. That's why sine theta over theta will remain positive. So sine theta is greater than theta, and sine theta over theta will be less than, we are interested in sine theta over theta, so we are dividing by theta. So theta is a negative number, and when we do that, when we divide an inequality or both sides of inequality by a negative number, the inequality gets changed. So the greater than sign becomes the less than sign. So sine theta over theta is less than theta over theta, and theta cancel out. We are left with sine theta over theta less than 1. So this is one of our inequalities which we need to prove this limit, this left-handed limit. Secondly, tan theta is less than theta. It also gets reversed. In the right-handed limit, theta was greater than tan theta. And in the previous limit, or in the right-hand limit, theta was not greater, theta was less than tan theta. So here the value range we are considering is from minus pi by 2 and 0. Both of those are not included, minus pi by 2 and 0. 0 is not included because we are not interested in what happens when we are at 0, and negative pi by 2, it's not, tan goes to negative infinity for this value, so that's why we are taking this range but not including the endpoints. So repeating the same procedure, but this time theta is just negative, So multiplying by writing tan theta as sin theta over cos theta, and multiplying by cos theta on both sides. So when we do that, the inequality gets changed, less than becomes greater than, and because theta is negative, because we are finding the left-handed limit. So theta and theta cancel out, we are left with sin theta over theta is greater than cos theta, and when we combine both inequalities, we get cos theta is less than sin theta over theta is less than 1. And when we find the limit of all of these sides, same we do the same thing, that find the limit of we find the limit of this thing by simply putting theta is equal to 0. So we get 1 and 1 on the extremes, and the middle function, or the middle thing, this limit of sin theta over theta, when theta approaches 0 from the left hand side, it becomes equal to 1 by sandwich theorem. So we have proved that because both the left hand and the right handed limits were equal to 1, so this limit is equal to 1 when theta approaches 0.